Hi guys, good morning, and in this video we are going to see this problem 3 of bi-weekly contest. The contest was pretty simple except the last question, which involved lazy propagation on segment trees. Thinking was easy, but the implementation was pretty hard. But yeah, let's look at this question, which is you are given a zero indexed integer array nums, and okay, then array x is expressible in the form nums if there exists some integer. We take some integer from nums, okay, and the or bitwise or should be equal to x, okay. In other words, an integer x is expressible. It can be written as the bitwise or of some subsequence of numbers, which means we have to choose some elements from nums, and I should be able to get by oring all those elements to a number x. Return the minimum positive non-integer, which means it should not be 0, more than 0, is not expressible from nums. I need to return a number, let's say name it as x, and it should not be able to represent by the bitwise or of all the elements or choosing any of those elements from nums. What is that minimum value? As we can see that our nums can be pretty big and the number of array it can be just 125. Let's see this example. Okay, if I have 1, if I have 2, so let's see if it is bitwise or. So let's move on to the binary notations. It is 0 1 and 2 it is 1 0. So 1 is for sure it can be obtained because see, I'll go on from 1 2 3, right? So yeah, as I need to get the minimum. So let's brute force that. Okay, let's try with 1. Okay, 1 can be obtained. It's itself in the array, not possible. 2 can be obtained. It's itself in the array, not possible. 3, it can be obtained by bitwise or of 1 and 2 easily. So 1 1, not possible. 4, let's try. It can be obtained. I can get 3, I can get 1, I can 2, I can't get 4. Oh, so it is the first non-negative element, positive element, non-zero, sorry, element which can't be obtained. So it is the answer. Now let's see this one. 2 3 5 binary representation. It is 1 0, it is 1 1, it is 1 0 1. Now let's start with 1. Can I obtain it? I cannot. Can you see it? I cannot. So yeah, 1 is my answer. Now when you think of this, so one thing you can think for sure, right, that I always started by looking at this. Okay, can I obtain 1? Can I obtain 2, 3, 4, 5, 6, 7? So I always thought of, okay, let's try 1, let's try 2. So yeah, let's try it out, right? Okay, let's try 1. We can obtain it. If we are in the array like this, the array is now empty. Let's build our array ourselves and let's see the element ourselves. Array is empty. Is it possible to have 1? It's the smallest element. It needs to be there for to get any. You do any or by any element. It's the smallest element, right? You can't get it. For sure, I can't get it. So it is the one element, 1. If it is not in the array, I'm pretty sure no matter what I do, I can't get it. 2. Is it any way possible that I can get it? Any way possible I can get it. Anyway, I'm asking any way possible. No, right? Because it's the smallest element for which it is 1 0 and you can't get it. Like you just have any other element. Bigger element, it can never make a 2. Smaller element is just 1. It can also never make a 2. So it's also not possible to get it. Anyhow, I'm saying, let's see 3. Is it possible to get it? Yeah, if the array has 1 or 2, it's possible to get it. If the array has 1 or 2, it's always possible to get it. It's always possible to get it. Yeah, it's always possible to get it. So what we can now say is that 3, it's possible to get it. Okay, 4, is it possible to get it? If I see that, okay, 1 0 0, it's the smallest element with 3 places where it is 1 0 and 0, and no other element smaller than this is able to make my this 100, so it's not possible to get it. Let's see 5. Is it possible to get it? 101. Okay, if I take a 4 and a 1, I can for sure make a 5. Oh yeah, it's possible to get it. 6. Is it possible to get it? 110. If I take a 4 and a 2, is it's possible to get it? Okay, it's possible. 111. It's possible to get it? Yeah. By just taking 4, 2 and 1. It's possible to get it. 1000. No, right? Because any minimum element, it can never make a 8 by bitwise OR, because ultimately it will give a 3 binary places, which is not possible to match 4, and any bigger element can never make a 8 because it's always more than 8. So it's not possible to get it. So now you can just simply see that, okay, 1 you can't get it, 2 you can't get it, 4 you can't get it, 8 you can't get it. Did you see why you can't get it? Because it's the smallest element in that particular range, which means that in that particular, if I have 5 places to place any binary number, so it will be the smallest number to be placed for those 5 places. So it will never be possible to get those numbers. Oh, that's amazing. And to always get a number, which is, let's say, to always get this number 7, if my below binary numbers are present, it's always possible to get this number. Now we have reached a conclusion that, okay, I just need to see what's the first missing power of 2. Is it 1? Is it 2? Is it 4? Is it 8? Is it what? Because rest are the numbers, because if 1, 2, 4 is present, then I can always make an element up till 7. So I don't have to worry about any of these numbers, because for sure if any of these 3 numbers are present, I will always be able to make up till all these numbers. So I will just look, okay, what's the first occurrence of all these power of 2 which is not present? Because if it is not present, so let's say if I say, okay, this number 4 is not present. So if it is present, then I always will be able to make a number 3, right? But if this 4 is not present, then no matter whatsoever above is there, I will never be able to make this 4. So it will be the first number which I will never be able to make. So I will just have to iterate over all the powers of 2 and see if I am able to make a power of 2 or not. If I'm not, then I'm good. So I'll just have a map in which I will store all the elements occurrences. If I was able to arrive at those elements or not, then I'll just iterate on the power of 2, which is 1, 2, 4, 8, 16, 32 and so on, and whatsoever have not occurred in this array firstly, which means that if I am on 16 and it has not occurred, then it is my answer. Why it is my answer? Because all these elements have been occurred, and with all these elements I will always be able to make all the elements less than 15 by doing a bitwise OR. So no matter what, if there is a 5, there is a 7, there is a 10, there is any value which is less than 15, I will always be able to make it. And no matter what the elements are after 16, but with all these elements I would never be able to make a 16, right? But if there are some elements after this 16, then I will have no worries, because bigger element can never make ORs and make a smaller element, right? So it's just that now it is my minimum element and I'll just return this value. So I'll just break as soon as some occurrences of power of 2 is not found. I'll just return its value directly. Is just nothing, because here it will never land, as it is said in the question itself that we will always have, and the limit is 25. So it will always have a number which is for sure not present. I hope that you guys like the video, and yeah, until then, have a good day. See ya. Bye bye.